Now we're going to begin lesson 2.3, part 2. As a reminder, a conditional statement is an if-then statement. Okay. If represents the hypothesis, Q represents the conclusion, so a conditional statement is denoted by if P, then Q. Okay, now we're going to talk about the converse. The converse of a conditional switches the hypothesis and conclusion. Okay. Because we're switching the hypothesis and the conclusion, the symbols also change, and these symbols for a converse read if Q, then P. Okay. So what we're going to do first, in example 1, we're going to write the converse of each true conditional statement. Then we're going to determine whether the converse is true or false. If a statement is false, we're going to find a counterexample. Now, a counterexample is an example that shows a conjecture is not true. If the statement is true, we're going to write the biconditional. Okay? Now, a biconditional can occur if the conditional and the converse are both true. Again, we can write a biconditional when the conditional and the converse are both true. So if the conditional and the converse are both true, you may write the biconditional using the phrase if and only if. Now, what is a biconditional? A biconditional is the conjunction or the joining of a conditional and its converse. Okay? In order to write the biconditional, both the conditional and the converse must be true. And then P and Q are combined using if and only if. Now, the symbol for the biconditional is still P first, then Q, but the arrow's going both directions, signifying the if and only if. Okay. All right, so in example 1, it says, if you live in San Diego, then you live in California. This is a true statement. I always like to identify the hypothesis and the conclusion. The hypothesis is the phrase that follows if. So you live in San Diego is the hypothesis. The conclusion is the phrase that follows then. So you live in California is the conclusion. Now, the first thing that we're going to do is we are going to find the converse. Okay, the converse switches the hypothesis and the conclusion, but we still keep the if-then statement. So the converse would be if, but we're going to switch. So if you live in California, I'm going to abbreviate California, CA, then you live in San Diego. Okay, so notice the if and the then stayed in place, but I just switched my hypothesis and conclusion, P and Q. Now, we need to determine if this statement is true or false. So if you live in California, then you live in San Diego. Now, that might be true. You could live in California and live in San Diego. But it's also possible that I live in California, but I live in San Francisco. Or in California, I live in Sacramento. Or in California, I live in Los Angeles. Okay, therefore, this statement is false. And the reason that it is false is because I can live in California, but I don't necessarily have to live in San Diego. So anytime the statement is false, we are going to give a counterexample. For the counterexample, the hypothesis remains the same. So I have to live in California, but I could change the conclusion. I don't have to live in San Diego, so I could live in LA. Okay, this is a counterexample because we're still in California, but the conclusion, you live in San Diego, is not true because I could live in LA. Okay, let's try another one. if two angles form a linear pair, then they are supplementary. Now we're going back to some of our properties, theorems, definitions. So if two angles form a linear pair, so two angles form a linear pair is my hypothesis. They are supplementary follows then is my conclusion. Okay, so the first thing I need to do is write the converse. The converse of the conditional switches the if and the then. So if they are supplementary, then two angles form a linear pair. Okay, so this is the converse. I switch the hypothesis and the conclusion. So we need to determine if this is true or false. So if they are supplementary, then two angles form a linear pair. So I have to determine if I can have two supplementary angles that do not form a linear pair. And the answer to that is yes. So this statement is false. Just because I have two supplementary angles does not mean they have to be a linear pair. Okay? Now your picture doesn't have to be a statement. Or I'm sorry, your counterexample does not have to be a statement. Your counterexample could be a picture. So I have two angles. Okay, one angle is 80 degrees. The other angle is 100 degrees. Those two angles are supplementary, but they're not a linear pair. Together, they are not adjacent and form a straight line. So this would be an example of a false converse with a counterexample. Okay. Okay, let's look at the next problem. If two angles are complementary, then the sum of their measures is 90. Okay, this is a true statement. Complementary angles are two angles whose sum is 90. So my hypothesis, two angles are complementary. My conclusion, the sum of their measures is 90. First thing I'm going to do is write the converse. You write the converse by switching the hypothesis and the conclusion. The converse would state, if the sum of their measures is 90 degrees, then two angles are complementary. Okay, if the sum of their measures is 90 degrees, then two angles are complementary. This converse is also true. Okay? Since both the conditional and the converse is true, we can write what is called a biconditional. And this is the joining of two statements. Okay? Now to write the biconditional, you separate the hypothesis and conclusion of the conditional with the phrase if and only if. So if you look at the original conditional statement, the hypothesis or two angles are complementary. So I'm going to write that without the word if. Okay. After I write the hypothesis, I'm going to write the phrase if and only if. And then I write the conclusion. The sum of their measures is 90 degrees. Okay. So a true conditional and a true converse yields a biconditional. Two angles are complementary if and only if the sum of their measures is 90 degrees. Okay. Let's try one more. If two lines intersect to form a right angle, then they are perpendicular. Okay. Two lines intersect to form a right angle is the hypothesis. Conclusion, then they are perpendicular without the word then. Okay, so this time I'm going to talk through it and I'm going to let you write it down. So the converse switches the hypothesis and the conclusion. So if they are perpendicular, then two lines intersect to form a right angle. I'll say that again. If they are perpendicular, then two lines intersect to form a right angle. This is a situation when both the hypothesis and the conclusion is true. Since the hypothesis and the conclusion are both true, I can write this statement as a biconditional. Okay? To write the biconditional, you separate the hypothesis and the conclusion with the phrase if and only if. So my biconditional would be two lines intersect to form a right angle if and only if they are perpendicular. I will repeat that. We drop the words if and then. Two lines intersect to form a right angle if and only if they are perpendicular. Okay, I will let you finish up this last problem, and then I'm going to have you turn to your Unit 4 workbook and practice a few problems on your own. Good luck.